In this video, we will look at an application of the chain rule to a profit revenue cost question. So here's this example. I actually want to give you the chance to try this problem first. So pause the video for about 4 to 5 minutes this time and try this example. So 4, 3, 2, 1, pause the video. Pause the video for about 4 to 5 minutes to try this example problem. Alright, so hopefully you've done that. Hopefully you've paused the video for about 4 to 5 minutes to try this. So let's talk about it together now. So this problem gives us this demand function for a product. It gives us this cost function. So the demand is in terms of the variable P, where P is the unit price in dollars. And the cost function is in terms of the variable X, where X is the number of items. And part A of this example asks us to find P prime of 10. So this is the derivative of profit at 10. So it's implied here that this 10 is in terms of price. So 10 here represents the price of $10. Okay, so we want to know what the derivative of profit is when the price is 10. All right, so profit is equal to revenue minus cost. So we need the revenue and we need the cost. So let's begin by trying to get the revenue. So let's get the revenue. Okay, so revenue equals P times Q. But we want to get this in terms of one variable. So this is P times, and we have this formula for what Q is, so let's plug that in. It's 4,000 minus P cubed over 200. And if I distribute the P in, we get 4,000, one more zero, P minus P to the 4 over 200. All right, so that's our revenue function. We got it in terms of the variable P. Let's do the same thing for cost now. So let's get the cost also in terms of P. In terms of P, because we already have the cost function. It's just in terms of a different variable, in terms of X. So let's get it in terms of P. Okay, so we know cost as a function of X is the fourth root of X squared plus 30. If I scroll it up a little bit, we can see that that's our cost function. Okay, so the variable X here represents quantity. It's the number of items. But we have another variable for quantity, which is Q. So X is the same thing as Q here. So I could write cost as a function of Q by simply changing the X to a Q. And I get Q squared plus 30 inside of this fourth root. So again, I can do that because X and Q both represent the same thing here. It's the number of items that get sold. Okay, but I want to try to get this in terms of P, which is the variable that my revenue is in terms of. All right, so to do that, to get my cost in terms of P, we're going to have to plug in our formula for Q. And that was Q is 4,000 minus P cubed over 200. So that's what Q equals. And then I got to square that. Then we have this plus 30. In fact, let me put that squared in a different color. Squared plus 30, and this all is within a fourth root. So now we have a revenue function and we have a cost function in terms of the same variable P. So we're ready to write down the profit. Okay, so we are ready now to write the profit. All right, so the profit is going to be the revenue minus the cost. So the revenue was 4,000 P minus P to the 4 over 200. And then I have to subtract the cost. So let's subtract this fourth root of 4,000 minus P cubed over 200. That whole thing squared plus 30. All right, so we have this profit function. Now we need to take the derivative. Because remember, the problem was asking us to find the derivative and then plug 10 into that derivative. All right, so one simplification I'm going to make is if I have to take the derivative of a big old fourth root, it's helpful to think of the fourth root as a power. A fourth root is a 1/4 power. So I'm going to rewrite that fourth root as a 1/4 power because it makes it easier to take the derivative of. All right, so now let's begin to take the derivative. Okay, so the derivative. So the derivative, so p prime for the derivative. Derivative 4000p is just going to be 4000. And now with p to the fourth over 200, we do not need the quotient rule for this. To take the derivative of this, the 200 on the bottom it's a constant. This is the same thing as having minus 1 over 200 and writing that in front. And then times p to the 4 like that. So there's no quotient rule needed for this. No quotient rule needed. No quotient. Oh, I don't like the way that's spelled. So let's see, no quotient rule needed. If we move that 200 to the front and write it as negative 1 over 200, p to the fourth, it's just power rule. All right, so doing that, now the 4 comes down. And when the 4 comes down, we'll have minus 4 over 200. And then p to the 3. Okay, so if we had wanted to do quotient rule on this because we see the fraction, we could have. It's not wrong to use the quotient rule there, but it just would have been longer. It was quicker to make this observation and avoid using quotient rule. Okay, so we have that, and then okay, so now the next term, we got the minus, and for this whole thing, we are going to need the chain rule. So for this whole thing, we are going to need the chain rule. So with the chain rule, first we deal with the outside part. So the outside part is the fact that I have this 1/4 power. It's kind of like I have p to the 1/4 as my outside function. So I bring that 1/4 down, and then I subtract 1 from the exponent. So that'll give me a negative 3/4 up there from my exponent. And then when I do that, when I take the derivative of the outside portion, we keep this inside the same. So we keep writing 4000 minus p cubed over 200 being squared plus 30. Okay, so that's the first part of the chain rule. The next part of the chain rule is we multiply this by the derivative. So I'm writing ddp for my derivative. And I'm writing ddp because my variable is p here and not x. The derivative of the inside. So the inside of this 4th power was, we had 4000 minus p to the 3rd over 200 squared plus 30. Okay, so what's left to do is take the derivative of this thing in blue, the ddp of this thing in brackets here. Okay, so the first part of this is going to stay exactly the same. So just to save time, I'm just going to copy that. So the first part of this, everything up to here is going to stay the same. I'll just copy that just to save a little bit of time. And then I will paste it. Okay, let's squish that down a little bit to give myself a little bit more room. All right, and now let's take, that 4 didn't copy over super nicely. So it's a negative 3 over 4 in that exponent. And now I have to multiply by the derivative of this stuff that's left over here. Okay, so to take the derivative of that, I need chain rule again. So we actually need chain rule again for this. So more chain rule. More chain rule here. Okay, specifically I need chain rule for this part up to the squared. Because there's an outside function there. It's p squared. It's the fact that I have this squared to deal with. And the inside function is everything within this parentheses. So chain rule says deal with the outside first. Bring that power down. And then my new power is going to be a 1 because I subtract 1 from the exponent. When we do that, keep the inside the same. So keep the inside as 4000 minus p cubed over 200. And then we multiply by the derivative of the inside. So the derivative of the inside is going to be, so the derivative of 4000 is 0. And the derivative of negative p cubed over 200, we've already done that once. That was here. So that's negative 4 over 200 p cubed. Actually, you know what? I messed up there. That's not what it is. Sorry, I need to take the derivative of p cubed over 200. I was looking at p to the fourth over 200. So to take the derivative of p to the third over 200, it's also going to be power rule. So I'll bring the power down, and I'll get negative 3 over 200. And then I'll get p squared, because I subtract 1 from the exponent. Okay, so that's what the derivative of the inside is. Okay. So just like in the last video, I'm starting to do more than one of these chain rule sort of steps in the same line. The more of these problems we do, the more of these steps I'll start to just do in the same line rather than spacing it out over several lines. And then finally, we have to take the derivative of 30, but that's a constant, so that derivative is just 0. All right, so that's the derivative of this whole thing that's in the brackets. We need a chain rule to take the derivative of this whole thing in parentheses being squared, and then the derivative of 30 was just 0, because that's a constant. All right, so at this point, we have finished taking our derivative. So the problem said once we take the derivative, we'll then plug in 10. So we need to now let the price be 10. And when we do that, we get p prime of 10. So I've gone ahead and plugged this into a calculator ahead of time. It ends up being about 3,980.01187. I've rounded it to 5 decimal places. Okay, so that is my derivative at p equals 10. All right, so that's what part A wanted. Okay, one more part to this example. Interpret your answer in part A. So pause the video. Pause it for about 1 minute to try this question. Maybe 1 or 1.5 minutes. 4, 3, 2, 1, pause the video. Pause the video for about 1 minute to try this question. All right, so hopefully you've done that. Let's talk about it together now. So interpret our answers from A. So what this derivative tells me is the it's the approximate marginal profit. Or in other words, this says if we were to increase the price, if price were increased from $10 to $11. So if we increased that by 1, then the derivative gives us an estimate. So we estimate how much our function changes. In this case, we're taking the derivative of P, derivative of profit. So it's going to estimate how much profit changes. So we estimate the profit changes by 39.80, that amount. And because it's positive, that means we're estimating that the profit is going up. The profit increases. We're estimating the profit increases by that value, by 3,980.01187. And that's our interpretation. All right, so in terms of our goals for this section, we have finished our last learning goal, which is applying the chain rule to a cost, revenue, profit example.